Good morning, everyone. My name is Habeeb Farah. I'm Software Engineering Group Director at Cadence. I manage the engines team in Jasper. I'm going to present to you today machine learning solutions in JasperGold platform. Starting from motivations behind this. So Cadence JasperGold proof grid technology and engines have evolved beyond what most users can follow. One size fits all default settings miss out on optimization opportunities. Looking on a per property, we have tens of proof engines, we have tens of engine options, we have tens of option values. Altogether, it's more than thousands of combinations, so it's countless of proof strategies. The other motivation is that the growth in JasperGold platform usage went way faster than growth of the formal experts community. Over the past 4 years, we've seen around 20% CAGR of growth on average of the number of formal users of Cadence. And even in the last year alone, we had 44% year-over-year growth in the formal users. So the formal experts are busy in deploying the formal verification methodology in their projects, and manual handcrafted tunings of engine settings is becoming very costly for them. So from here, the demand for out-of-the-box fully automated performance is on the rise. So the message we're getting from our users, formal experts and also new users, is give me your best out-of-the-box performance. I'll take care of the proof problem, you take care of the engine's automation problem. Another motivation behind our machine learning work is that to drive forward the model checking scalability inside our engines, we keep researching and building new algorithms, and great ideas require great efforts to make things to become on by default. So some heuristics are always good. So it's easy to turn it on by default, and let's say this is an example here. So what we're seeing here is the time to determine a property, and we're comparing the first algorithm under study versus the reference, which is the baseline. And in this case, most of the results are below the diagonal line. That's why this is something easy to make on by default. It's expected to give always speed up. Now, while some other heuristics, they have mixed results, and we can see here an example. So this could be something in the early stages of the research. And then the question is actually how to bring something from this form into the form above so that we can turn it on by default. So sometimes this process could take more than a year to materialize, and this is really becoming very costly, but at the same time, this is required to keep driving the formal verification scalability. So I presented 3 motivations behind why we boosted our proof automation power using machine learning techniques, and we're gonna go into these later on. Starting with some glossary for this presentation. So what is machine learning? It's the study of algorithms and statistical models that computer systems use to perform specific tasks effectively without using explicit instructions. Usually it's combined with a machine learning model. It's an approximative model for a function automatically generated from training data that allows inference over new data. Reinforcement learning is a machine learning task that allows computer systems to automatically and dynamically determine the ideal behavior within a specific context to maximize its performance based on observation, reward, and action. Supervised learning, a machine learning task in which the algorithm builds a model of unknown function from a subset of its inputs and the desired outputs. In this type of learning, one needs to supply labels to the output data. Presenting to you the smart proof technology, which is the wrapper that puts in it all of the proof automation. It's built from 2 sections. One is learning and the other one is machine learning. So what's on the learning, which is on the left side? So it's mostly about optimizing subsequent runs / regression. So we're learning from previous historical runs, and this learning is based on proof profiling data, and is also based on proof caching. So with proof profiling data, we keep engine level settings that worked before. In proof caching, we reuse existing result if property and logic are unchanged. Now this is learning because this is based on the properties. It could be by name, could be by resemblance, or so on. On the other side, we have the machine learning part where it optimizes out of the box proofs. And here we have two items. With the first one is the multi-advisor proof orchestration, which uses machine learning to find best macro level settings. And we have the engine algorithm selection, which uses the machine learning to set best algorithm at the micro level inside the algorithm of the engine. So altogether, this system, this is a smart proof technology, and during this presentation, we're gonna focus on the machine learning part of it. So the system of automation is also known as the proof orchestration, and if you want to look on the deployment timeline, in 2016 we didn't have this automation in. So in 2017-03 we introduced the first generation of the orchestration, which does reinforcement learning by explore-exploit techniques. 2017-12 we introduced the proof profiling data to drive the learning for subsequent runs. And 2018-06 we introduced the proof caching. It's enabling proof results to be restored based on property matching. Now in 2019-03 we introduced the multi-advisor orchestration, which is the second generation of orchestration, and it uses machine learning and custom engines, which I will describe later on. But all in all, we can see that we have already 3-4 years of automation based on machine learning inside JasperGold, which is very successful, and it runs out of the box and delivers the good performance. Another view of this, so we have the smart proof technology and we have the algorithm selection, which we mentioned briefly. It's the micro level learning and selection of algorithms. So it's done using supervised learning. Machine learning uses training data from 500 customer designs at least, and supervised inference, best fit core engine selected and configured to create custom solver. In terms of performance, demonstrated up to 4x better out of the box proofs, or 2x on average. The other part is the multi-advisor orchestration. It's a multiple proof advisors use reinforcement learning to improve proof efficiency. Introducing the multi-advisor proof orchestration, an overview. So a group of advisors with different weights provide recommendations for different strategies to be run during a proof, and the composer or the system, by continuously analyzing the proof messages and results, the tool dynamically adjusts the proof strategy by updating the weight of each advisor using the machine learning strategy of reinforcement learning. So the advisors, they send out recommendations, and the system itself, the machine learning system, will be composing recommendations for the engines, and then based on results, these results will be fed back to the scorer, which will update the weights and the awarding for each advisor. The other technique is the algorithm selection concept, and we're going to give here the example of engine B. So the challenge that we started with is that JasperGold platform has different technologies that are used internally by engine B. Challenge is to choose the best engine B parameter configuration to run on each given property. The approach is we use supervised learning to create a machine learning model trained on internal benchmarks across multiple customer designs to try to infer on the fly better than default engine B configuration on each given property. And this solution is wrapped up in a new engine called engine B4. So the inference evaluation against engine B showed overall performance boost when using engine B4. This is the scatter plot where on the y-axis we have engine B4, which is the machine learning based one. On the x-axis we have engine B, which is the reference, the baseline. And anything below the diagonal line is a speed up. What we can see here, actually, we're seeing very good speed ups on the right hand side of the graph. And this is lots of value or lots of speed up on the hard properties. Actually, the scale is logarithmic, so anything above this point is actually 100 seconds run. So we're talking here very nice improvement over the hard properties. Now, putting everything together, I'll be presenting here benchmark results, property performance and convergence. So we have two benchmarks, and those benchmarks are demonstrating the out-of-the-box performance progress across the last 3-4 years. And of course, this is it's included here the machine learning based solution for proof automation, and also the advancements in model checking heuristics and algorithms, and also the synergy between the machine learning layer and the algorithms that are being added newly. So on average, we saw about 14x speed up in the last 3 years on properties from test cases where the test cases had full convergence. And here we're measuring average per property time to converge. So we're seeing average 14x the last 3 years. We're seeing also average of 1.6x in 2019. So the trend keeps progressing. Another benchmark which is showing, actually this is hard convergence benchmark, this set of test cases that do not fully converge, and here the goal is to get better convergence, more convergence year over year by reducing the number of non-converged properties. So we see on average 3.2x non-converged reduction in last 3 years, and in 2019 we see average of 2x non-converged reduction in 2019. I mean, some of the amazing things here, we see some test cases that were able to fully converge with the with these advancements that we're doing. Again, this is thanks to the machine learning based proof automation, and also it's thanks to the new engines, heuristics that we're developing all the time, and mostly it's thanks to the synergy between both. To summarize, we presented the motivations behind the new novel proof automation in JasperGold formal verification platform. The machine learning based solutions deployed successfully in JasperGold platform and delivering great out of the box automation. At this point, I'd like to thank you for listening, and let's have some time for some questions. Thanks.